Hi, I'm John Rybczyk. I'm a professor at Western Washington University in the Department of Environmental Science. This is my graduate student, Pete Kairos, and this is Caitlin, a local high school student. And we're here in Padilla Bay looking at rates of elevation change and how sea level rise might affect the bay itself. If you look around here, what you can see is we're on a pretty low tide right now. They do get lower, but we're pretty low right now. And you can see vast areas of eelgrass exposed, which is one of the most productive systems in the Pacific Northwest. So there's a high interest in preserving these kinds of ecosystems. They're home to birds and crabs and fish of all kinds. In fact, I think I just saw here someplace. Let me see if I can find it again. Let me try to get this up. Nice. Here's a molting Dungeness crab. Ow! Right here. Oh yeah, let's see. Oh, this is not a Dungeness crab. I think this is a graceful crab. It's still pretty big. Nice. Anyway, home to all kinds of organisms that we're trying to preserve. And one of the problems facing these kinds of ecosystems around the world, just not in the Pacific Northwest, is that sea levels are rising. And the question is, what will happen to these types of systems as the sea level rise? Systems like this can respond in two ways. One is that they can accrete at the same rate that the sea level rises. By the way, I broke my leg, that's why I have this stuff. This isn't special marsh gear. So as the sea level rises, the marsh can also accrete sediments and keep pace with it. And surprisingly, coastal wetland systems have a good ability to do that. Another thing that can happen is that they can escape laterally, is that as the sea level rises, the marshes can move inland. But if you take a look at the shore here, you can see that there's really no room for lateral migration. There's bluffs and dikes and levees. So there is no real opportunity for a gradual transition upland in these types of systems. So as sea level rises, these types of systems will end up getting squeezed out of existence if they can't accrete at a rate to keep pace with sea level rise. And so that's what we're doing here today. I'm showing you some of the devices that we have installed to measure what's actually happening elevation-wise in these types of systems. Because the first question we have to answer is this system currently accreting? Are sediments accreting? And if so, at what pace? Or is this actually an erosive system? Are we losing sediments, which would exacerbate the problem of sea level rise and would spell eventual extinction of these types of seagrass beds as the seas rise and rise and the land sinks and sinks. So I'm going to show you these systems here and how we work them. All right.
So what is this?
Well, what we've done here is we want to very carefully measure whether these systems are accreting or eroding over time. And so what we've done here is that we've installed across this bay 23 stable benchmarks like this. This is the tip of the iceberg here. Pete and I came in here about 6 years ago, and well, Pete wasn't with me back then, but he installed some of them later. And our pipes are actually sunk down into the ground about 30 to 40 feet. And so we pounded them into the ground until basically we couldn't pound them any further to make this stable benchmark.
Okay.
And then we cemented it into place. You can even see a little bit of the cement, so it really doesn't move. So we have these stable benchmarks now all throughout the bay. And so it doesn't move. What does move is the land. You know, the soil either accretes or it subsides. So we can these stay in the marsh, they stay here. And we can put this leveling device that Pete has here on top of this and level it very precisely and measure the exact distance from that leveling device to the bottom of the marsh. And so over the years we can see whether this marsh is accreting or not, and that will give us an idea as to whether this marsh is keeping pace with sea level rise right now. And the rate of sea level rise is supposed to increase. So we can make predictions about whether this system might be able to keep pace with that rate of increase too. And so this is really one of these types of systems are being installed all over the United States and even the world now to answer this particular question as to, how is our system doing with regards to sea level rise. It's one of the most accurate ways we have to do this. The U.S. Geological Survey is sponsoring a lot of these programs around the coasts.
Why don't you just use like Google Maps and GIS?
Well, that's a good question. A lot of people do try to do that, but the problem with that is we're talking about changes about this much a year, a centimeter a year or less, and the resolution of those maps and using GIS on standard survey techniques, the resolution is like this. And it would really take maybe 20 or 30 years for that to happen in the marsh. So you just don't have the kind of resolution. The error that is propagated by those types of measurements are too great to answer the kind of questions we have to ask. So we need to have these highly accurate type of systems in place to do that. And nothing is better than this good old-fashioned just leveling to do that kind of thing. We'll set it up to show you. Not only can we take very accurate measurements, but we can take many measurements. Because if you look at the marsh, it's not a uniform surface. Here's some pieces, a seaweed, there's a crab, a clam, some grass, So if you just measured in one place, every time it's going to change a little bit, and that introduces error as well. But with this device, we can take 9 times 8 different measurements around this whole site and get lots of measurement, and that all those multiple samples kind of factors out the variation due to the little topographical changes that we see in the marsh. So that's another great thing about the set, is you get a lot of measurements, not just accurate ones, but lots of them. So this is the surface elevation table, is what we call it, and it's the leveling device that hooks on top of this stable benchmark that we put here. And so this doesn't stay out in the field, of course, we bring it with us. They're made down in Louisiana, because Louisiana was one of the first places that was noticing the effects of sea level rise along the coast, and so they started making them down there, and there's still a place that makes them for everybody that uses them around the world. And so one of the nice things about this is that we can hook this up here and level it. There's a little leveling bubble right here, and we can perfectly level it so it's nice and straight. And then there are 8 different positions, and we can rotate this around the points of the compass and put it into 8 different positions, drop these pins down right to the level of the marsh, and measure how far it is basically from the top of here to the level of the marsh. We actually measure from here to here, but it's the same. So we can measure this exact distance from here to here very accurately, and how it changes over the course of the years. And then we can move it over here and measure it here, and measure it here, and then measure it here. Now there are 8 positions, but we have sacrificed 4 of them. We don't actually measure anywhere over here because we're walking over here, and that messes everything up. So we try to be very careful, approach it only from this side, and only measure here where we never walk. And so we lose a little bit of data that way, but of course it's much better than measuring inside a footprint, which can equal about 100 years of change in the marsh. So we definitely don't want to sit there. So the next step is, once it's leveled, is to carefully drop these pins. This is the hardest part because you got to reach way over, but carefully drop these pins right to the level of the marsh. And now what's nice is that Pete has been doing this himself probably for the last, what, Pete, 3 or 4 years?
Yeah, 4 years.
Last 4 years. So you may ask the question, well, where exactly do you drop it to? And the sediments are kind of soft, but Pete has been doing it, and doing it the same way, the same person, every single year for the last 4 years. So we have nice stability there in terms of the procedures that we have used. So then the next thing we have to do is, can you grab me a pencil there? I'll record, and Pete will measure, the exact same place in the exact same way that he measured last year and the year before and the year before and the year before. What pin number are we on here, Pete?
This is number 6.
Number 6, okay. So measure the first pin position first.
34.0.
Okay.
33.8. Number 3 is 34.4.
Interesting. Okay, so I'm just eyeballing it here, but it looks like we've lost about 3 or 4 millimeters since the last time we took our measurements here. But that's, again, just eyeballing it. We'll put it in the computer, and we'll get the exact data here and do a regression equation and look at how it's changed over the last 6 years. All right.